Okay, right. So last time we were talking about parasailing. So then we saw the relationship between departure and D long, which is departure divided by D long is equals to gross latitude, and then you saw that you cannot take D long as the distance measuring unit. So the east-west distance in nautical miles is basically departure. Now we are going to look at, so if you can remember, I was talking about three types of sailing. The first type was you are going east and west. The second, sorry, the first type was you are going north and south, right? Then the second type was east and west. Then the third type I was explaining that there will be uh, this type of sailing, northeast, northwest, southeast, southwest type of sailing. Then we saw that it can be like what is mainly for a navigator, what is required by a navigator is basically your course and distance. So in order to find out the course and distance in the third type of sailing, you have plain sailing, then you have Mercator sailing, and you have great circle sailing. Okay, so we are going to look at plain sailing today, and so this is between when you are sailing from one location to another location, and when you are sailing from one location to another location, you can see that your latitude is also changing. This is latitude B, right? This is latitude B, and this is latitude A. And also your longitude also change, right? So this is longitude A, and this is longitude B, right? So here you can have various courses. So we are going to find out the course and distance using the plain sailing today, right? So we'll come back to the Mercator sailing. I mean, in future we'll be doing the Mercator sailing and the Great Circle sailing, but today we are going to focus on the plain sailing, right? Uh, Plain sailing today is bit obsolete. We are not using plain sailing, right? It was used in, I mean, when the the older seafarers was doing navigation, they were using plain sailing. But present day navigation, you are not using plain sailing much. Basically, you are using Mercator sailing. So the important sailing type of all this is Mercator sailing. But for the sake of understanding the subject, you have to learn about other types of sailing as well. And because Mercator sailing and everything was derived by the fundamentals of plain sailing. Right. So, can you all hear me? Okay. And can you see what I'm writing as well? Okay. Okay. Now, so the plain sailing is happening uh, is basically when you travel from position A to position B, where your longitude and longitude are both are changing. So, but we say that plain sailing, you can use it for 600 miles only. If your distance is less than 600 miles, right, then you can use plain sailing. But if your distance is more than 600 miles, you should not use plain sailing, right? Because why it is called plain sailing is between the 600 nautical miles, we consider the earth as flat. Okay, මම මේ ටික සිංහලෙන් කියන්නම්. plain sailing වල අපි plain sailing use කරන්නේ ලැටිටියුඩ් එකයි ලොන්ජිටියුඩ් එකයි වෙනස් වෙද්දී. ඒ කියන්නේ A ඉඳලා B යද්දී ලැටිටියුඩ් එකත් වෙනස් වෙනවා ලොන්ජිටියුඩ් එකත් වෙනස් වෙනවා. හැබැයි ප්ලේන් සේලින් කියන එක අපි යූස් කරන්නේ ඕගොල්ලන්ගේ ඩිස්ටන්ස් එක මැක්සිමම් 600 miles වෙනකන් විතරයි. So maximum 600 miles වෙනකන් Earth එක flat කියලා තමයි consider කරන්නේ. එතකොට සාමාන්‍ය ත්‍රිකෝණමිතිය එහෙම නැත්නම් trigonometry use කරන්න පුළුවන්. right? හැබැයි බැරි වෙලාවත් curvature එක 600 miles එකට වඩා වැඩි වෙච්ච ගමන් curvature එක වැඩි වෙනවා. එතකොට සාමාන්‍ය ත්‍රිකෝණමිතිය පාවිච්චි කරන්න බෑ. එතකොට special mathematics section එකක් එනවා spherical trigonometry කියලා part එකක්. ඒකින්ද තමයි මේ 600 වෙනකල් plane sailing use කරන්නේ. ඊට එහා ගිය රික්වයර්මන්ට් එකක් තියෙනවා මේ 600 miles කියන එකට. ඒක ඔයගලන්ට පස්සේ සේලි තේරෙයි. මොකද අපි ඒක පස්සේ ටොපික් එකක් එනවා mean latitude sailing and mid latitude sailing කියලා එකක්. ඒ දෙකක් ඒක තේරුම් ගනිද්දී ඔයගලන්ට තේරෙයි ඇයි මේ 600 miles කියන එක ආවේ කියලා. ඉතින් සාමාන්‍යයෙන් පොත්වල කියලා තියෙන 600 miles වෙනකන් විතරයි plane sailing කරන්න පුළුවන් කියලා. ඒක explain කරගෙන ඇයි එහෙම වෙන්නේ කියලා. So අපි බලමු මේ ඉස්සරහට යද්දී ඇයි ඒ 600 miles කියලා ඒගොල්ලෝ කියලා තින්නේ කියලා. So now so let's look at how to prove the plane sailing. මොකද දැන් plane sailing කියන්නේ කියලා අපි prove කරමු. So you have to basically remember what is departure is. Departure is what basically? Departure කියන්නේ මොකද්ද? The east-west distance, this is east, this is west, distance in nautical miles. That is departure. Just remember the definition, okay? East-west distance in nautical miles. Distance in nautical miles. So that is departure, right? So now when it comes to plane sailing, you can see, assume that you are moving from this point to this point, A to B. Okay, you are moving from, I will show you, can you see the picture?
Yes, sir.
Yeah, so assume that you are moving from F to T. In my case, I have drawn it as, in my screen, I have drawn it as A to B. Okay, so you will be going, because the Earth is a curvature, you are basically going in a small curvature, like this. Okay, so but we can consider, because it's a small distance, less than 600 nautical miles, we can consider that the longitudes are parallel to each other. Okay, so what I'm going to do is I'm going to divide the latitudes, right? Let me draw it like this. 1 minute. Okay, there will be a small curvature like this. So what I'm going to do is I'm going to divide this A to B into equal n number of latitudes. That means I'm going to divide this one into equal B lat. Okay, so what I did was this distance, this distance, this distance is equal to each other. Okay, are we clear? So for example, if this is x distance, this is also x, this is also x, this is also x. So d lat between these parallels of latitude. Are we clear? So assume that I have divided into n numbers. Okay. Then where the latitudes are meeting, this is where your longitudes are. Okay. So if I take this triangle, you can see this is the departure of the small triangle, and this is the distance that you travel, and this is the d-lat. Can you see that? Are we good?
Yes,
Okay.
sir.
Okay, so the same way I can take this triangle and this triangle, it's the same thing. So if I divided this small curvature into several triangles, you can see they are going to be straight lines. As much as I increase the number of triangles, here in this case 4 triangles, if I increase it to 100 triangles, it is going to be basically the curvature will become straight lines. This become straight lines, right? So I would put I will put C here, D here, E here. Anyway, this is B, right? So let me put it in different colors. So I will put C here, D here, E here. And this point is F, G, H, this is I. Okay, right. So in that case, now what will happen is that, right, since we consider the small triangle ACF, just consider ACF triangle, right? You can see when you consider the ACF triangle that it is basically a flat triangle where I can use flat trigonometry. I don't need to use since the ACF triangle is small, since the Earth is very large, so this small triangle will become a flat triangle. And your AB distance is less than 600 nautical miles. That also you have to remember. So total distance here is less than 600 nautical miles. Okay. So you can use the plain sailing with if your distance is less than 600 miles only. Otherwise you cannot use it. Okay. So in that case, so if you have any some kind of a uh, misunderstanding that you can use plain sailing of to whatever the distance, no, you can't. That is why I said plain sailing is very much obsolete now. Nobody is using it, right? Unless otherwise you want to understand the subject, you have to learn it. So anyway, now since the if you consider the small triangle, but now you know that this is north. Okay, since this is north, this angle is going to be the cos. This is your cos, isn't it? As I as I explained earlier, you can consider the this longitude and this longitude are parallel to each other because of the small distance. Okay, because of the small distance, you can consider these two longitudes are parallel to each other. So because of that, this cos will be equal to this angle as well. From trigonometry, you know that. From mathematics, you know that these two um, causes are equal to each other. Okay, because these two lines are parallel to each other. So that means ACF angle is your cos. Okay, are we good, guys? All right. So in that case, you can see by using trigonometry, not trigonometry, yeah, using trigonometry, you can I can show you that. Uh, Let me change the direction. 1 minute, guys. I will change the direction of. Right. No, that's not going to work. Okay, let's do it like this. Okay. Can you see my screen clearly? I'm not sure people who have logged on from mobile phones whether you can see it clearly, but I strongly suggest you use a computer or something to log on so that you can see clearly what I'm writing. Uh, and so anyway, uh, then the ACF is cos, ACF angle is cos. So now I will take the triangle out, and this is A, this is C, this is F, and we show that this is the cos. Okay, and this is the distance, this is the dlet, and this is the departure. So by using trigonometry, dlet divided by distance equals to cos cos, isn't it? Dlet divided by distance is equals to cos cos. Are we good? So dlet equals distance into cos cos. Okay. So now from that you can see that now you can see there are several triangles here. Triangle 1, 2, 3, 4, and we can continue that one. Right. So there are several triangles, and now since we have divided this A to B distance by n number of triangles, if I multiply this dlet by n number, n dlet, both sides needs to be multiplied. Then from mathematics you know that both sides needs to be multiplied by. So this will become cos. Okay. So n dlet equals to n distance. But now you can see n times dlet means the total dlet between A and B. N times dlet means because I have divided into 4 n's, n into n into n into n 4 times means 4 times dlet is the what you call dlet between A and B, right? So n dlet will become dlet of AB. Then n distance, you can see since we took A and B as flat surface, all the distance will be equals to each other. That means AC will be equals to AC is equals to CD equals to DE equals to EB, right? So from that we can say that n times into distance is equals to the total distance between dlet, sorry, sorry, it is the total distance between A and B equals cos cos. Are we good? Can you understand what I did? Okay. If you have any questions, please ask, okay? You can always ask questions, so don't worry. Then next one is, let's look at what will happen to departure. So now you can see departure divided by distance is equals to sine cos. Departure divided by distance is equals to sine cos. Okay. So because of that, departure is equals to distance into sine cos. Okay. So then I will do the same thing. I will multiply it by n number of departure into n number of distance into sine cos. Then n number of departure, you can see that n number of departure, right, is equals to the total departure between A and B. So it will become the total departure between A and B. And in the anyway, previously we explained that n number of distance will become the total distance between A and B into sine cos. I will take this as the second formula, and the first one is this. Then I am going to divide the second formula by the first one. Second formula divided by the first one, what I will get is departure AB divided by d lat AB is equals to distance AB into sine cos divided by distance AB divided by into cos cos. Distance AB into cos cos. Now you can see distance AB will be cancelled each other. So departure divided by d lat is equals to sine cos divided by cos cos is basically tan cos. Are we good? Okay, you can even see it here. Departure divided by d lat is equals to tan cos. Okay, so let me go back to. Alright, so are we good, guys? Okay, so this is how you prove the plane sailing. This is the plane sailing formula, but you don't have to prove anything. Okay, I just proved you to show you how this came. This is plane sailing formula, right? You don't have to by heart this one. No, you don't have to explain anything in your exams how the plane sailing came in, right? But since I'm mixing the principles of navigation into practical navigation, so we are doing everything in combined, because there is nothing called principles of navigation and practical navigation. Everything is navigation. Okay, so this is the plane sailing formula. From this, we have to derive the other parts in the plane sailing formula. But now you can understand that one thing is that when you move, now we have to find out the departure and the delat between the two positions. Let's say you are going from A to B, right? So you have to find out the departure between A and B as well. Okay. Then also you have to find out the DLAT. So DLAT is not an issue because DLAT you can see it is straightforward. But the problem is departure. Right? If you take this distance as the departure, if you take this distance, that is not departure, that is D long. But we proved that you cannot take D long as the distance. So now the problem comes in, right? Then what departure we have to take? All right. So let's do it like this. Let's assume that you are, uh, let me take, let me draw, okay, assume that you, this is the equator. Give me a minute, guys. Okay. Assume that you are moving from A to B like this. Okay. When you are moving from A to B, when you are moving from A to B, okay, you can see that you cannot take, you cannot take this latitude B. Okay, this is latitude B and this is latitude A. So you cannot take departure of latitude B. You cannot take the departure of latitude A as well because you can see that does not represent your actual departure. What is departure? Departure is the east-west distance in nautical miles between A and B. You can see if I put here C and if I put here D, um, if I put here C and D, if I put here C and D, CB does not represent, CB also showing a departure. AD is also showing a departure. Now which one is the correct departure for A and B? East-west distance. Now you can see it is pretty much difficult to find, say which one is the correct departure. Okay. So in that case, what we do is we are going to find out the mean latitude to find the departure between A and B. Okay. So we are going to find out the mean latitude between A and B to find out the departure. But the problem is this does not represent the actual departure. So the actual, assume that the departure, the actual departure between these 2 points is represented by this line. Okay, the actual departure is represented by this line. Okay, the red one. Okay. දැන් මම ආපහු කියන්නම් සිංහලෙන් A ඉඳලා B ට යද්දී මොකද මේක ටිකක් පොඩ්ඩක් සමහර කට්ටියට පැටලෙන්න පුළුවන් මේවා ලොකුවට මං හිතන්නේ ඔයගොල්ලන්ගේ එක්සෑම් වල හයි කියලා මොකද මේවා ටිකක් ඩීප් පොයින්ට් එකක් මම මේ කියන්න යන්නේ මේ mean latitude and middle latitude කියන කතාව. ඒකින්ද මේක මේ තේරුම් ගන්න පුළුවන් කට්ටිය තේරුම් ගන්න උත්සාහ කරන්න. A ඉඳලා B යද්දී departure කියන්නේ east west වලට east west distance එකට මැන්නම nautical miles වලින් ඒක තමයි departure කියන්නේ. හැබැයි ප්‍රශ්නේ කියන්නේ A ඉඳලා B යද්දී latitude එකත් වෙනස් වෙනවා longitude එකත් වෙනස් වෙනවා. දැන් මේ අපි පෘථිවිය ගත්තොත් පෘථිවිය earth එක ස්පියර් එකක් හින්දා මේ east west distance එක හරියටම අයින්න අමාරුයි. එතකොට actual එක, ඒ කියන්නේ ඇත්තටම අපි east west ගමන් කරපු දුර මේ රතු පාට ලයින් එකෙන් තමයි පෙන්වන්නේ. ඕකේ, ඒක තමයි actual එක. right? හැබැයි අපිට ඒක හොයාගන්න ටිකක් අමාරුයි. ඒකට හොයාගන්න දාන්න තියෙන ෆෝමියුලා එක ටිකක් සැර වැඩි. ඕකේ. ඒකින්ද right මේ actual AB distance එක එන latitude එකට තමයි okay මේ actual distance එක මේ actual east west okay 1 minute මේ actual distance එක එන latitude එකට තමයි අපි කියන්නේ mid latitude කියලා. mid lat කියන්නේ ඕකට. ඕකේ. මොකද්ද mid latitude කියන්නේ? මේ A and B යද්දී එයාගේ actual departure එක පෙන්වන latitude එකට. හැබැයි ගාන හදන්න අපි ඒක ගන්න නෑ. ඒක පොඩ්ඩක් බරපතල වැඩි හින්දා අපි ගන්නෙ middle latitude කියන එක. sorry mean latitude කියන එක. ඉස්සගාවේ middle latitude එක 1 minute guys. ඉස්සලාවේ mid latitude එක අපි ගාන හදන්න ගන්නේ mean latitude. mean latitude එක කියන්නේ B සහ D අතර latitude එක එකතු කරලා දෙකෙන් බෙදුවම එන අගය. මේකට කියන්නේ mean latitude. okay so mid latitude කියන්නේ එකක්, mean latitude කියන්නේ තව එකක්. පටලවා ගන්න එපා. මේක මේ පොත්වල දැක්ක එක බය වෙන්නත් එපා. in simple terms mid latitude එක කියන්නේ ඒක තමයි actual A and B departure එක. එහෙනම් අපි ගාන හදන්න ගන්න ඕනේ mid latitude එක. ඒ වුණාට අපි ඒක ගන්නෙ නෑ. මොකද හේතුව ඒක ටිකක් හොයන්න අමාරු හින්දා mean latitude කියන එක තමයි අපි ගන්නෙ. මම පස්සේ ගණන් හදලා පෙන්නන්නම්. ඔයගොල්ලන්ගේ දැනුම සඳහා for your knowledge I will show you the difference between the mid latitude and mean latitude by calculations. Right? But I will do it later on, which is bit advanced for you guys. ඒක පොඩ්ඩක් ඔයගලට advance වැඩි. ඒකින්ද ඒක එච්චරම තේරුම් ගන්න උත්සාහ කරන්න යන්නත් ඕනේ නෑ. අවශ්‍ය වෙන්නෙත් නෑ ඔයගලන්ට. right? so මට පෙන්වන්න උවමනාව තිබ්බේ mid latitude කියන එක සහ mean latitude එක අතර difference එක මොකක්ද මේ කියලා. okay so now in our case දැන් අපි ඉස්සෙල්ලා දැක්කා departure හොයන්න ඕනේ. දැන් මේ departure හොයන්න අපිට බෑ. හොයන්න නම් A and B අතර departure කෝකද කියලා දැන් හොයාගන්න. ඒක ඒ හේතු හින්දාම අපි මේ වෙලාවේ මේ plain sailing ගානට mean latitude කියන එක තමයි use කරන්නේ. ඒකට හේතුව මේ දෙන්න බොහොම ළඟින් ඉන්නේ 600 nautical miles වලදී. 600 nautical miles අපි flat කියලා A and B flat කියලා හිතනවා. ඒකින්ද මේ දෙන්න ගොඩක් ළඟින් ඉන්නේ. A and B ළඟ ඉන්නේ. A and B ළඟ විතරක් නෙමේ, ඒ ළඟ හින්දා mid latitude එක සහ mean latitude එක අතර gap එක හරිම අඩුයි. මේ gap එක 600 nautical miles වලදී ගොඩක් අඩුයි. ඒකින්ද අපිට assumption එකක්, approximation එකක් හැටියට mean latitude එක ගන්න පුළුවන්. okay මම මේ කියන එක තේරුණාද? do you understand what I said? have you understood? all right okay all right very good. so uh, again I want to tell you guys, I'm not worried about your STCW exam. I'm worried about how much you know about navigation. Okay? because we are all Sri Lankans, you should know the subject, you should know about your job and your profession. So I'm not worried about how you about passing your STCW exam. You can pass the exam like nothing by hearting the sums and doing the sums. Okay, because every time it's the same sums are coming. So if you know how to app how to do the sum, you will be okay. You can pass. But that does not mean you have understood the subject. Okay, so that's why I'm going pretty much deep into the subject to explain certain principles. Um, all right, so how to find the mean latitude? In order to find departure, if you can remember, the departure in parallel sailing formula, the departure was given as, right? Um, in parallel sailing, departure divided by d long is equals to what? මේක හරිද? මේ parallel sailing formula එක. Is it correct? This is parallel sailing. Is it correct, guys? කො නිදිද? You guys are sleeping. I wanted to hear the voice because sometimes I'm checking my voice even, whether you can hear.
Yes, yes, yes. That's good, sir.
That's all clear, sir.
All right,
All clear, sir.
so now in this case, now you can see since we are using latitude, which latitude you are going to use? A or B to find the departure. So you can see now you cannot use A latitude or B latitude. Instead, as I explained earlier, we are going to use the mean latitude. So the formula will be in plain sailing. We are going to change the formula like this. Departure divided by d long is equals to mean, sorry, cos mean let. Okay, this is the first formula in plain sailing. Because the reason is I explained earlier why we have to use the mean latitude and why we are not taking the mid latitude, and this is the reason. So now this is the first formula. By using this formula, you can easily find out departure. So if you can find out the departure, now in the previously proved formula you saw that departure divided by d is equals to tan cos. Okay. So before I move on to that, let's see what type of sailing triangles you will be getting in plain sailing, right? You have only 4 options of sailing. That is, you will move towards northeast, southeast, southwest. These are the directions that you will be moving, isn't it? Now we have to draw the required triangles. So how to draw the required triangles? Okay. In the first case, you can see that now, as I told you north and south is the most powerful. Okay. The the the, the main cardinal marks. Okay. Now what you have to do is, it's very simple. You can draw the triangles like this. First, you draw the cross, otherwise you will be doing mistakes. So you can follow my method if you want. You can draw the cross first, then draw north and south, then draw east and west. These are the triangles that you will be getting. You will not see this in books, but that's why I told you I'm giving you simple methods. I'm not following books. So this will give you the required triangles. Why I did this one is because this is north, this is south. So your courses, if you can remember the quadrantal courses that I was explaining last time, always starting from north or south. So north towards east, north towards west. Okay. The quadrantal courses are always starting from north or south. North towards east, north towards west. Okay, this is south, east, south, west. So this one in this case, south towards east, south towards west. Quadrantal courses. Are we clear? Now you may see in books like this. It is the same thing that I have drawn. It's the same thing, but I did it in a way that you can remember what you are doing. Otherwise, some people are going. I have seen when I'm correcting the question papers, I have seen some people have drawn the courses like this, triangles like this. Sorry, the opposite. I have seen some guys are drawing the triangles like this. This is wrong. Okay, this triangle is wrong. That's why you will not do any mistakes if you follow the method that I told you. So how to do that? If you have a piece of paper and a pen, you can also do it now. What you have to do is you draw the cross, draw north and south, draw east and west. Then you will never do any mistakes. Are we clear? Okay. So I will do it one more time. Okay. You draw the cross, draw north and south, draw east and west. That's it. Okay. Right. Now, when you do this, okay. Now, now you can see this is distance, this is departure, and this is delay. Okay. Let's say you are moving, your vessel is moving towards A to B here, A to B. So you can see you are moving towards northwest. So since you are moving towards northwest, the triangle that you are supposed to use is this one. So you just take the triangle out and you have to draw the triangle like this. So this is A, this is B. So your departure is going to be this one, distance is going to be this one, this is going to be delay. Are we clear? And this is going to be the quadrantal course. So your answer will be coming in quadrantal course. Then you have to convert it into the 3-digit course. Are we clear, guys?
Yes, sir.
All right. So let's do a sum and see how to calculate So what are the formulas that we are going to use? We need to find the course and distance. So that is the fundamental requirement for a navigator is the course and distance. So by using the plane sailing, we are going to find out the course and the distance. So in order to find out the course and distance, we need the departure, we need the delat. Okay, so in order to find delat is straightforward. If you have the two latitudes, you can find out the delat. But when it comes to departure, it is not straightforward because you have to use another formula, which is departure divided by d long equals to cos mean lat. All right, so let's do a sum. Okay, the first sum. Vessel in vessel A in position A, okay, and the vessel will be in 10 degrees north, 20 degrees east. Position B is 25 degrees north, and okay, let me draw it properly, otherwise you will be doing mistakes. Latitude, longitude, 10 degrees north, 0 degrees east. Latitude, longitude, 5 degrees north, 0 to 5 degrees east. Okay, so now let's do this sum. So what if you can remember, last time I was explaining how to write this one. So position A, latitude and longitude. Position A, position, you can do the sum, okay? You can do the sum, and also if you found out, I mean, if you can find the answer, please put the answer here. So position A, 10 degrees north, longitude 0 to 0 degrees east. 10 degrees north, 0 to 0 degrees east. Okay. Then position B is, this is B. Position B is 15 degrees north, 0 to 5 degrees east. If you can remember, please draw these two so that you will not do a mistake. You are in 10 degrees and you are moving on to 15 degrees. So that means you are moving towards north. And what is delat? 5 degrees. Okay. Then you are in, this is J, you are in 20 degrees east and you are moving on to 25 degrees east. So this is anticlockwise, which is easterly, 090 course. Okay, so the difference is 5 degrees. But I told you, I remember I told you last time, you cannot use the degrees, you have to convert it into minutes. So when you convert the delat into minutes and the d long into minutes, delat you convert it to minutes, then it is going to be, you have to multiply it by 5. 6 into 5 is 300 minutes north delat. D long is 5 into 60, which is 300 again, easterly D long. Now it's very easy to draw the triangle. It's going to be one of this triangle, and you can see you are moving towards north and east. So the triangle is going to be this triangle. Northeast triangle is this. Okay. So remember always in your answers, when you write answers, write everything and draw the triangle. I have seen some people are not even drawing the triangle. If I am correct in the papers, I will not give you marks. The reason is that you have to understand the fundamentals and you have to show that you have understood the fundamentals. So now you have to draw the triangle. Okay, so what is a triangle? You can see first you draw the north and go to east, because I told you always north is powerful, north and south is powerful, right? Then you will automatically get the triangle. If you wish, you can do it like this, or you can do it like this. You go to north first and go to east next. Don't go to east and go to north. Then your triangle will be wrong. Okay. So you always go to your first, as I told you, the towards your powerful cardinal. That is north here. You go north, then go to east. Right? Then this is going to be A and B, and this is going to be the distance between A and B, and this is going to be the departure between A and B, and this is going to be the DLAT between A and B. Now you have already found DLAT, which is 300. But now we need to find the departure. So in order to find the departure, what you need, because departure is equals to d long divided by cos mean lat. Okay, then you need to find out mean lat before we proceed. So what is the mean lat? So mean lat is equals to latitude A plus latitude B divided by 2. In this case, latitude A is 10 degrees, latitude B is 15 degrees. So your latitude is 10 degrees north plus 15 degrees north divided by 2. So your mean lat is going to be 10 degrees north and 15 degrees north divided by 2 is going to be 12.5 degrees north, or we can say 12 degrees 30 minutes north. Are we clear, guys? All right. Okay. So now you guys are following me, right? I'm not sure whether you can.
Yes, sir. Yes, sir.
Yes, sir.
Okay. So mean lat is done. So now we have already found out the d long in the previous case. So now we can apply it to the formula. So in this case, I will directly apply departure is equals to d long into cos mean latitude. D long is 300 and cos mean lat is 12 degrees 30 minutes north. What is the answer, guys? What is the answer? 292. Okay. Cos 5. 292.89. Are we clear? Okay. So just remember, when you are writing, in this case, I got it for 1 decimal place. Okay. When you are writing your distance, right, as it's prudent that you you write this first and then you round it up to the first, what do you call it, you round it up, right, to a full number, that is 293, right? So it's good that if you do this 293 nautical miles, because but you always show at least one decimal place here, right? At least one decimal place. But if you're writing a angle, for example, cos, right? It's always better you write the cos with a full number, right? But always if it is quadrantal cos, you keep the quadrantal cos with one decimal place. Later on you will see, later on I will show you. But for the time being, just remember, if it is 3-digit cos, let's say you have to write like 300 degrees, don't write it like this, 300 decimal 1. Don't write it like this. Always 3-digit coses we are writing in full numbers. 300 degrees, true. Let's say your answer is coming something like this if your answers are coming like 298.8 degrees true. So write this, after you find out this one, write it as 299 degrees true. Okay, don't write 3-digit with a decimal, right? These are standards that I'm saying, telling you, okay? Then if it is a quadrantal course, it's always better you write one decimal place. Let's say north 89.2 degrees east. It's better you always show one decimal place, right? Then if it is a distance 292 decimal, you show at least two decimal places, 292.89, then you round it up to 293. Show it like this. Are we clear? All right, okay. Now departure, we have found out the departure as 292.89. When you're doing the calculation, you take this one, not the rounded up value, right? Since it is not a distance, we have to take, I will wipe out this one because it's not distance. I just wanted to explain how to use the distance and the course, how to show the distance and the course. So in this case, you have to use it like this, 292.89, right? Because furthermore calculations are there. Then we go into the triangle. Now in this case, this is your cos, right? So you can see departure divided by distance is what? Sine cos or what? So we can use the plane sharing formula. What is that? Departure divided by d is equals to tan cos, right? If you can remember the plane sharing formula that we proved earlier, departure divided by d into tan cos. So we can use that formula straight away here. Now departure divided by d is equals to, even here you can see that departure divided by d into tan cos. All right. So departure divided by d is equal to tan cos. Now we have to find out the tan cos. Departure is 292.89. D is how much? 300. Previously we found that it is 300. D is 300. So the cos is going to be, what is the answer, guys?
09782
0.9. No, the cos.
So 44 degrees, 18.78 minutes.
Okay, so you have to use tan inverse in this case. Now this is coming 0.9763. 0.9763. This is what I'm getting. Correct me if I'm doing arithmetic mistakes. 292 decimal 89 divided by 300. Yes, 0.9763. So you have to use tan inverse 0.9763, and that is how much? Tan inverse 63 is 44 decimal 3. Did you all got the answer? Is the answer is correct?
Yes, sir.
Answer එක හරිද?
No, sir. 44 degrees, 18.7 minute.
18.7. Ah, you mean minutes? No, no, no. Minutes minutes වලින් හරි මේක 0.316 වලින් වැඩි කරා minutes වලින් I just kept it as the because you are not going to find out minutes in a course. So now this is, as I told you earlier, you keep this for one decimal place. That is enough. Decimal places තියන minutes වලට convert කරන්න යන්න එපා. course එකක්නේ. අපි course minutes වලින් කියන්නේ නැහැ. Are we clear?
Yes, sir. Yes.
Okay, right. So now, as I told you, this is going to be a quadrantal course. මොකද අපි course එකක් කවදාකවත් ලියන්නේ නැහනේ. courses අපි ඔයගොල්ලෝ chart එකේ දැකලා තියෙනවද මේ course එකක් ඇඳලා තියෙනවා second officer මේ මෙහෙම දාලා 044 degrees 18 minutes කියලා ඔහම දාලා දැකලා තියෙනවද? ඒකින්ද minutes දාන්නේ නැහැ අපි සාමාන්‍යයෙන්. course එකක් පෙන්නද්දී. decimal places වලින් තමයි අපි හදන්නේ. Are we clear? All right, okay. So in that case, 44.3 degrees is basically, you can see your quadrantal course is towards northeast, right? So as I told you, this is not your 3-digit course, this is your quadrantal course, northeast. Why? When you, this course will never exceed 90 degrees. ඔගයන්ගේ මේ කෝස් එක කවදාකවත් අංශ ගණුව වැඩි වෙන්නේ අංශ ගණුවට වඩා වැඩි වෙන්නේ නැහැ නේ මේ ට්‍රයැන්ගල් එක එහෙම විසඳන්න බෑනේ. ඒකින්ද මේ එන්නේ quadrantal course එකක්. So this will not exceed 90 degrees. So now we have to convert it to, this is how you write it. Okay, this is the proper way of writing your course, quadrantal course, at least one decimal place. Okay, now we have to convert it into 3-digit courses. So how to convert it? Automatically you can see it's the same thing when you convert into north is 44 degrees point 3 means this is your 3-digit course as well. So the 3-digit course is 044 degrees to I emitted the decimal place. Can you see that? I just sorry omitted. Okay, not emitted. I just omitted the uh, the decimal place. Okay, so when you are writing 3-digit courses, do not put decimal places, but when you are writing quadrantal courses, make sure that you put at least one decimal place. And if you are writing a distance, the next one is, now we have already found out the course. Now we have to find out the distance. So the next one is finding the distance. I will show you how to write the distance. So in order to find the distance, what is the formula that we can use? You can use any of the formulas. You can see dlat divided by distance is equals to cos, for example. So dlat divided by distance is equals to cos by trigonometry. You can see dlat divided by, in this form, in this triangle, you can see dlat divided by distance is equals to cos. Oh, you can use departure divided by distance is equals to sine cos. Whatever you want to use, you can use. Okay. Uh, right. So dlat is 300. So in this case, distance is equals to, let me convert, distance will go up, this one will come down. Okay. So distance is equals to uh, dlat divided by cos. Okay, so dlat is 300 cos is, in this case, do not use your 3-digit cos because we are not using a decimal place, right? Always make sure that you use the quadrantal cos, 44.3 degrees. Do not use do not use your 3-digit cos. Okay, you always have to use your quadrantal cos. This is the right one, this is the wrong one. Do not use it. Okay, so if there is a decimal place, use your 1 decimal place to find out the answer, right? So now the answer is going to be, what is the answer, guys? Okay, since I am using a normal calculator, there will be a small difference from what you are using and what I am using. Okay, so don't worry about that one. I'm using a normal calculator. So what I'm getting is 419.17. Okay, but anyway, you may be getting something around 2 something, right? So that's fine. So this is the distance. Always make sure that you write 1 decimal place for your distance. Okay, you always write 1 decimal place. Previously I showed you uh, when you're writing the departure, you can round it up. After you show the departure, you can round it up, but if you are using a departure for any calculation, make sure that you use your decimal places. Okay, so next one, if you're writing a course, make sure that you write your quadrantal course with 1 decimal place and your three digit course, no decimal place, no decimal. Okay, are you clear? Then when you are writing a distance, even in the chart, at least better you write 1 decimal place. And when you are doing any calculation, If you are using the course, do not use 3-digit course. You always use your quadrantal course. Otherwise, there will be an error in your answer. Are we clear? All right. So the course and distance between A and B is going to be course and distance of AB is 0.44 degrees 2 and 419 decimal 2 nautical miles. So this is your answer. Are we good? Are we clear, guys? All right. Okay. All right. So let me show you now the difference between the mid latitude and the middle latitude. After that, uh, we can do some questions. Let me one moment, please. Okay. Can you all guys see? Can you all see my screen? Okay. Now I was explaining the difference between the main latitude and the mid latitude. Okay. I was explaining about the mean latitude and the mid latitude. Now here you can see that the yellow color is the mid latitude. That means CD is the mid latitude, AB is the mean latitude. But if you want to find out the mid latitude, this is the formula. So can you see, as a navigator, it's not prudent to use this type of formulas. පේනවනේ the mid latitude එක හොයන්න තියෙන formula එක. Okay. පස්සේ මම ගණන් හදලා පෙන්නන්නම්. You don't need to do this. I will show you that there is a difference between the main latitude and mid latitude කියලා. Right? උදාහරණයකට දැන් මේක අපි විසඳුවොත් එහෙම ලැටිටියුඩ්ස් දෙකකට මීන් ලැටිටියුඩ් එක සහ මිඩ් ලැටිටියුඩ් එක අතර ඩිෆරන්ස් එකක් ඔයගලන්ට පෙනෙයි. හැබැයි හරියටම නැවිගේෂන් කරනවා නම් යූස් කරන්න ඕනේ මිඩ් ලැටිටියුඩ් එක. මීන් ලැටිටියුඩ් එක නෙමෙයි. ඕකේ. ඒක තමයි හරිම ඩිපාචර් එක දෙන්නේ. Are we clear? ඒක නිසා තමයි අපි මර්කේටර් සේලින් වලට යද්දී අපි මීන් ලැටිටියුඩ් එක පාවිච්චි කරන්නේ නැහැ. මර්කේටර් සේලින් වලදී. right? ඒකට අපි වෙනම මෙරිඩියෝනල් පාත්ස් කියලා වෙනම එකක් පාවිච්චි කරනවා. එතනදී එන්නේ මිඩ් ලැටිටියුඩ් එක තමයි අපි යූස් වෙන්නේ. මිඩ් ලැටිටියුඩ් එක යූස් කරලා තමයි එතකොට අපිට 600 nautical miles වලට හිර වෙන්න ඕනේ නැහැ. ඊට වඩා ඩිස්ටන්ස් එකක් වුණත් සේල් කරන්න පුළුවන් මිඩ් ලැටිටියුඩ් සේලින් එක කරලා. right? So guys, let me explain back again. As I explained earlier, the mean latitude is not the correct latitude that we should use to find the departure. It is the mid latitude. CD is the mid latitude, AB is the mean latitude. So CD, as I explained earlier, CD means the actual departure. So where the actual departure is happening. AB is mean latitude, it is not the actual departure. But since we are doing plain sailing for 600 nautical miles, AB and CD is very close to each other, so no problem, the error is negligible. But if we are doing long distance sailing, we should not use mean latitude. Instead, we are using the mid latitude, and the formula you can see, this is the formula that we should use to find out the mid latitude, but it's very complicated, right? Because of that, for simplicity of navigation in Mercator sailing, we are using the mid latitude, but we are not using this formula. Instead, we are using a simple table which is called meridional paths. You will later understand that in our next session, right? So I hope you have understood the difference between the mean and mid latitude. Why I am putting so much of time here is that anybody can do sums by hearting, but you will not be able to do sums in a certain situations if you do not understand the principles, right? For example, the parallelism questions that I sent you earlier is pretty much some of the questions are very hard, right? You may find difficulties unless otherwise you understand the principle. I'm sure some of you will, for sure, you will do the sums, but some guys will struggle. So you guys are going to be navigators. So you should understand what navigation is in the first place, right? So that is why I'm going a little bit deep into uh, the explanations. So in the next session, I will show you, I will do the calculation. You don't have to do it. I will show you the difference between these two. So in the meantime, let's move on to one more sum in uh, plain sailing. Can you all see my screen, guys? Can you all see my screen? Yes. Okay. So please do this sum. I will also do it. You can also do it. So position A, latitude, 0, 1 degree, 30 minutes, north, longitude, 178 degrees, 36 minutes, east, position B, latitude and longitude, 0, 2 degrees, 14 minutes, south, longitude, 179 degrees, 30 minutes, west. This is plain sailing. Okay. Find the course and distance. Find course and distance. Find course and distance. Okay. You can do the sum. Please put your answers in the chat box if there is. Yes, there is a chat box. So you can drop your answer here and let's do the sum. So can you all see the sum, guys? Please take a screenshot if you have to, because I'm going to move up and down, right? So if you're ready, I can proceed. Please take a screenshot. Are we good? Shall I proceed? Have you taken a screenshot?
Okay, sir.
Okay, okay. So position A, position B, latitude, longitude, 01 degrees 30 minutes north, longitude is 178 degrees 36 minutes east, position B, 02 degrees 14 minutes south, 179 degrees 30 minutes west. So now let's draw this one. So you are moving from position A is in north, position B is in south. So you are moving towards south. Then this is D dash 178.36 east. A is here, 179.30 west. Oh, sorry, the opposite. 178.36 east is here, 179.30 west is here. So you are moving towards anti-clockwise direction. That means you are moving towards easterly. Are we good? Hagida? Okay, right. So let's find out how much this is. Now the problem comes in when it comes to the mean latitude. We will see later, but for the time being, we'll find out the DLAT. Two 224 minutes south, 3 into 60 plus 44, which is 224 south, and 36 plus 30 minus 60 is 6. Okay, 6 degrees, 180 plus 178, which is 358. 79 plus 78 plus 1, which is 358, and 60 minus 6 is 54, and 329. So it is going to be 1 degree 54 minutes. Okay, so 1 degree 54 minutes east, and that is 114 degrees east. So guys, the D lat and D long, is it correct? The D lat and D long is correct?
Yes, sir.
Yes, sir.
Okay, right. Now let's draw the triangle. And before we draw the triangle, let's find the mean lat. So mean latitude. Latitude A plus latitude B divided by 2. But in this case, remember guys, latitude A is north, latitude B is south. Okay. Now don't get mixed up here. Okay. I will tell you an easy method. That is, if north, take north as plus, and whatever is south as minus. Okay. Can you all hear me?
Yes, sir.
Yes.
Okay. මම මේ ලේසි ක්‍රමයක් කියන්නේ මේ වගේ අවස්ථාවක් ආවම north එක plus කියලා ගන්න. south එක minus කියලා අරගෙන එකතු කරන්න. වෙන මොනවත් හිතන්න යන්න එපා. Okay. So latitude A is north, that is 1 degrees 30 minutes north, plus I told you to take south as minus. Okay. So in this case minus 2 degrees 14 minutes south divided by 2. So you can see plus and minus is minus. So the answer is going to be 1 degrees 30 minutes, not minus 2 degrees 14 minutes south divided by 2. Okay. So the answer, if the answer comes as minus, then your mean latitude is in south. If the answer is plus, then your mean latitude is in north. But in this case, you can see it is minus once you subtract. Okay. So your mean latitude will be in south. So you go 2 degrees 14 minutes minus you go 1 degrees 30 minutes, and that is going to be minus 30, 44 degrees and 44 minutes. So 44 minutes, 0 degrees 44 minutes, right, is south is your mainland. Oh, sorry. We are divided by 2 as well. So the answer is going to be 0 degrees 22 minutes south. And since it is minus, the answer will be coming as minus. So that means your sign is going to be because when you subtract this one from that one, the answer is going to be minus. So your sign is going to be south because you took north as plus, south as negative. So this is mean lat. You got the answer? Mean lat?
Yes, sir.
Yes.
Okay, so this is mainlet. Now, let's go to the triangle. Now you have to draw the triangle. So what is a triangle? It is southeast triangle. Okay, you can see that it is the southeast triangle. So how to draw the southeast triangle? As I explained earlier, south is powerful. So you go south, then east. Sorry, east is other side. You go south and go east. Right? So you are moving towards south and east. A to B is here. You can see it here, south and east. Okay, so previous one, where did I go? This, not this. Okay, right. So southeast. So then we just basically this is distance, this is departure, this is the lat, this is the quadrantal course. So from mean lat you can easily find out departure. So your first formula is departure divided by d long equals to cos mean lat, which is departure is how much? 200 and sorry, d lat is 224 and d long is 114 east. D long is 114 east, so departure is equals to 114 east into cos mean lat is 0 degrees 22 minutes south, which is equals to my answer and your answer will differ a little bit because of the calculator that I'm using. Slightly, okay, not much. Okay, so cos 0 degrees so 22 0.367 4 2 cos 67. Departure is 113 decimal 99. Got it?
Yes, sir.
Okay. Now you can see it is very close to D log. Why? Can somebody explain why? It's very, very close to D log. Almost D log. Why? If you understood the principle, you will be able to answer this question.
So distance less than 600 nautical miles in.
No, 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 no. No. Departure එක එහෙම් පිටින්ම ළඟට ඇවිල්ලා තියෙනවා D long වලට. ඇයි ඒ? කියන්නේ almost D long. 0.99 නේ. Can somebody explain why?
So cos mean let එක 0 ආසන්න වශයෙන් බිඳුවට සමානයි.
මොකක්ද මේ what does it mean? ආසන්න වශයෙන් බිඳුවට සමානයි කියන එකේ තේරුම මොකක්ද?
It's sailing almost in the equator.
That is the answer. So in the equator, departure is equals to d long, isn't it?
Yes.
Departure 144. Please double check your answer. It cannot be 144. Okay, I cannot remember. I did not see who was that, but somebody have put your answer as 144. It's not going to be 144. Okay, maybe you have done a type mistake. It is 114 or 113.99. All right. Okay. So so departure is fine. Now we have to find out the course. So what is the formula we can use? The formula we can use is the parallel plane sailing formula, guys. Go. I have shown it here. Departure divided by dlat is equals to tan cos. That is the plane sailing formula. So plane sailing formula is departure divided by dlat is equals to tan cos so tan cos equals departure 113.99. The lat is 224, which is 0.5088. Yes. So the cos inverse tan inverse cos equals tan inverse tan inverse 0.5088, which is 27. I'm getting south 27.0. No, you don't need 27 south east. You all got the answer for the course? Is the course is correct?
26.97, sir.
How much?
26.97, sir.
26.97.
Yes.
Yeah, that is correct. So remember I told you to keep one decimal place. So when you round it up, what will happen?
Okay, sir. Okay.
So it will become 27. So southeast. So now how you convert it into uh, 3-digit course? You can see it is from north. It is going to be how much? 180 minus 27. So 180 minus 27, which is 153 degrees true. Okay, you have the course now. Then what else we need? We need the distance. So for the distance, you can say d light divided by distance equals cos d light divided by distance is equals cos. So distance equals d light divided by cos. D light here is 224 cos 27 degrees, and the distance is 251 decimal 4 nautical miles. So cos and distance of AB is equals to 153 degrees true and 251 decimal 4 nautical miles. This is the answer. You got the answer? How about the others? Are we good? Okay. Okay. So now let's summarize. What are the parallel sailing formulas that you have to use? Sorry, plane sailing formulas. Before we go to the plane sailing formula, let's look at your uh, 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 steps. So what is the first step? Find d let and d long. That is the first step, isn't it? Are we clear? So you can see what we did first is we just basically find out the d let and d long. Then we found out the mean let. That is your second step. Find mean latitude. After you find the mean latitude, what is your third step? You can use departure divided by d long formula, cos mean lat, to find, what are you going to find here? Departure. Sorry. Okay. So the fourth point is, after you find the departure, by using, what is the formula that we use? Before that, we have to draw the triangle. Okay. Okay. So we have found out the departure, then we have to draw the triangle. draw sailing triangle. Then the fifth one is after you draw the triangle, you can use the next formula. So now we have already found out the departure. Then you can use what is formula that we use. You can see here departure divided by d long. Departure divided by d lat is equals to tan cos. Use departure divided by d lat equals to tan cos and find cos. So the sixth point is convert the quadrantal cos to 3-digit cos. Next point. After you convert that one, you can use two formulas, whatever is convenient for you, right? In this case, the triangle you can see, you can use two formulas to find the distance. One is d lat divided by distance is equals to cos cos, or departure divided by distance equals to sin cos. So we write here the next step using d lat divided by distance is equals to what? Cos, you can see it here. D lat divided by distance is equals to cos, or departure divided by distance equals to sin cos. Find distance. That's it. Okay. Departure divided by distance is equals to sin cos. So this is plain sailing in detail, right, guys? I hope you followed. Any questions? So if you have nothing to ask, we can conclude. We try to upload the video, but I'm not sure when I can do this one because I'm pretty much busy these days. Yeah, do you have, I will send you some couple of questions, and I would like you to try those questions that I'm sending. Okay, otherwise I'm just sending and it will be lying there. So that you will see, and when you are answering those questions, maybe it can be answers, or maybe there is a mistake in the question or something, or you will find it out. Okay. If you don't have any other questions, we can wind up. Do you have any questions, guys? Are we good? Are we good? All okay?
Yes, sir. All good.
Okay. So then, see you and good night.
Thank you, sir.
Thank you.
Thank you, sir. Good night.
Okay, sir. Good night, sir. Thank you.
Yeah, good night.
Night, night. Good night. All right, see you guys.